All right, this is Module 4, Lesson 10 for 8th grade. This is looking at more of those proportional relationships we were working on in Topic A. So now we are looking at Topic B. So we're going to continue with those proportional relationships. So let's get with this question here. Paul walks 2 miles in 25 minutes. How many miles can Paul walk in 137.5 minutes? So what they're wanting us to find out is the value of time to the distance in the miles. Now, they already set up the first one for us. They gave us the 25 minutes and the distance being the 2 miles. And if you remember, this is my X and this is my Y. So we're going to continue this chart. Now, you could pick any numbers that you really want to, but I'm going to keep my numbers fairly simple. And I want to keep a constant rate going as well. So let's say if I went from 25 minutes to 50 minutes, okay? So you can see that these are doubling. All right, well, if I double this side, then I need to double this side. So this would become a 4 then. What if I increase this to 75? Well, then I would double this side again and get 6. What if I increased it to 100 minutes? Then that would go 8 miles. Now, you could also go from the Y to the X. You could ask yourself, if I went 10 miles, how long would that take me? And if you just kept the pattern going, you would get 125. Now, my table here did not get to 137.5 minutes. And with a fractional minute, being that 0.5 there, the half minute, you want to set this up like a proportional relationship just to make it easier to solve. So let's set up our first ratio that we have, and that is the 2 miles for 25 minutes. And we're going to set that equal to the comparison proportion. And that's the one we're solving for. So I know I have 137 minutes and a half, but I don't know how many miles that will get me. Now, the most important thing about setting up proportional relationships is that you keep the units across the same. You compare the same. So up here, I have miles. So over here, I need to be solving for my miles. Down here, I have minutes. So over here, I need to have my minutes. You need to have the comparisons going across from each other. Now, it doesn't matter if you had the minutes on top of the miles and the miles on the bottom. It doesn't matter. As long as it's consistent going across, then you'll be fine. So once you get it set up like this, we're going to cross multiply. So we have 25 times x, which would be 25x. And then we have 2 times 137.5, which gives us 275. Now from this point, we're going to divide by the 25 because I want to know 25 times what gives me 275. And since I don't know, we divide. Those cancel out because 25 divided by 25 just gives us 1. So we say cancels out. And 25 goes into 275 11 times. So my final answer is he can go 11 miles. All right, let's try the next one. All right. So Wesley walks at a constant speed from his house to school 1.5 miles away. It took him 25 minutes to get to school. What fraction represents the constant speed? All right, so we're just going to write down our fraction or proportion, however you want to think of it. I know that his school is at 1.5 miles away, and it took him 25 minutes to get there. So 1.5 over 25, and that equals my C for my constant. And they're using C here for constant speed instead of K. All right, let's look at B. You want to know how many miles he has walked in 15 minutes. Let Y represent the distance he traveled after 15 minutes of walking at the given constant speed. Write a fraction that represents the constant speed using C in the terms of Y. All right, so I know that we are talking about after 15 minutes, so that's going to be down here because my minutes was on the bottom, so I'm going to put it down here again. Now, I don't know how far he went. See, it says here how many miles? I don't know. So they want me to use that as a Y. And then all of this, once I find out what my Y would equal, would give me my new constant speed there. So if you notice, we have 2 unknowns. We have a y and we have a c, which means we have two variables, and that's okay. That's all they wanted us to do. So that's as far as we can take this problem at this point. Now it says, write the fraction from parts A and B as a proportion to solve and to find how many miles Wesley can walk after 15 minutes. So what this question is asking is we're going to take these two and combine them together and set them up like a proportional relationship. So here's my relationship from A, and we're going to set that equal to the relationship from B. Now we can actually solve these. All right. So again, as long as you have your miles across the top and your minutes across the bottom, then you're fine. So I'm going to cross multiply here. 25 times y gives me 25y. 1.5 times 15 is going to give me 22.5. Now this is asking me 25 times what gives me 22 and a half. Well, when you don't know, you divide. What you do to one side, you got to do to the other. Those cancel, and my y equals 0.9 miles. So almost 1 mile, but not quite there. Now let's look at D. D says, let y be the distance in miles that Wesley traveled after X minutes. Write a linear equation in two variables that represents how many miles Wesley walked in X minutes. All right, so we're going to set this up again as we have 1.5 over 25. And we're going to set that equal to y over x this time. Keeping the y from the original problem here from B, actually, B and C. But this time, we don't know the minutes. We don't know how many minutes it took them. So that's another variable. And on this one, we're going to still cross multiply. We won't get a final answer, but you'll see what happens here. We're going to cross multiply. And you get 25 times y is going to give you 25y. And then here you get 1.5 times x, and we're going to set that equal to 1.5 times x. Now at this point, I want my y by itself because you want to try to get your equations to always be in this kind of form. Okay, so I have the x over here already. I actually have my m, it's 1.5. So I need to move that 25 at this point. And just so I can get that x by itself. So I'm going to divide by 25, to get the y by itself. Divide by 25 here. So now I have the y by itself. So it's already starting to take form here of this type of equation. And then I'm going to keep the 1.5 and I'm going to divide that 25, keeping that. And since I can't really solve that any further, that's my final answer. And so when we start to solve equations with two variables, then you'll know what to do after this. But at this point in our lessons, you're just going to leave it just like this. All right, so let's move this up a little bit so we can answer that bottom question there. Number 2. Stephanie drove at a constant speed from her apartment to her friend's house 20 miles away. It took her 45 minutes to reach her destination. What fraction represents her constant speed? So again, this is just like the one we did up above where we have a 20 miles away, 45 minutes. So 20 miles away in 45 minutes, and they want us to use the letter C to represent constant speed. And that's it. All right, so let's look at B. What fraction represents the constant speed C if it takes X number of minutes to get halfway to her friend's house? All right, so this is, again, very similar to the ones we were doing up above. I'm going to say we have she was going for, I believe it was, 20 miles. Had to look back at the question. 20 miles. Well, her friend is halfway. Then we're going to divide this in half and we get 10. So we're going to use the letter or the number 10 here as our distance. Now, I don't know how many minutes it's going to take her there. So they want me to use X for that. And again, miles on top, minutes on bottom. And then they want me to represent this with the letter C for the constant. All right. That's all we can do at this point for that one. So write and solve the proportion using A and B to determine. All right, so we're going to combine those two that we created. So on A, we came up with 20 over 45. And on B, we came up with 10 over X. And now we can solve. So again, we're going to cross multiply just like we were doing before. I always like to do my variable one first. So I'm going to do 20 times X gives me 20X. And 45 times 10 gives me 450. Divide by 20. These cancel. And 450 divided by 20 gives me 22.5 minutes. All right, let's go to D. D says write a two-variable equation to represent how many miles Stephanie can drive over any time interval. Okay, so let's set that up. We know we have the 20 miles in 45 minutes because that came up at the very beginning here. And we know we have Y miles in any time of minutes. So that's where we get the two variables. And again, this is just like before. We're going to cross multiply. And this time I'm going to multiply so I have the Y by itself on the left side. I like the Y to be on the left side because again, we're looking for it to be in this format, okay, our standard format. So 45 times Y gives me 45Y. And then I have 20 times X gives me 20X. And just like we did on that last problem, we're going to get that Y by itself. So we're going to divide by 45. My 45s cancel. And I wind up with Y equals 20 over 45X. But I can simplify this 20 over 45. And when I do, my final answer here is, I'm going to put it right here, is going to be Y equals 4 over 9X. So that would be my answer for D. All right, I'm going to bring this up for number 3 here. Clear this out. The equation that represents how many miles Y Dave travels after X hours is the equation Y equals 50X plus 15. All right, so what we're going to do is substitute in these values of hours for X and solve for the Y. All right, so we're going to keep using this equation. And since I know I'm going to keep using that equation, I'm going to go ahead and just write all my equations real quick. So I have Y equals 50 times 2 plus 15. I'm going to come down here. Y equals 50 times 3 plus 15. Y equals 50 times 3.5 plus 15. And Y equals 50 times 4.1 plus 15. All right, so we're going to solve these out. I'm going to put my work over here on the side just so it's not so cramped up in that little box. So I have 50 times 2. Well, 50 times 2 is going to give me 100. And then I'm going to add 15 to that, so I get 115. Here we have 50 times 3. That's going to give me 150. And we're going to add the 15 to that, and I get 165. Okay, so I'm going to pull up my calculator here just to kind of help us out with these decimal ones. So we have 50 times 3.5. All right, let me move my color palette out of the way there. All right, so we have 50 times 3.5 is going to give me 175. And now I'm going to add that 175 plus 15. So notice I'm using a calculator and I'm able to show my steps. So I'm going to come over here and put plus 15 and I get 190. All right, last one. I have 50 times 4.1. So let's solve that first. So I'm going to come over to my calculator. 50 times 4.1 is going to give me 205. So I have 205 plus 15, and that's going to give me 220. All right, so that is today's lesson, and I hope that helps. Have a great one.